Today we're looking at the big one theory again, and this is part 4, how to use the number 1 when solving equations. So quick review, what is the big one theory? First of all, go back and watch my first big one theory video, number 1. It explains in detail. Basically, it's the understanding that 1 comes in many forms. So like 5 over 5, x over x, 5 to the 0 power, log 6 of 6, and all of these different ways that all equal 1. They are the identities. And you can use those forms of the number 1 to change parts of equations while preserving the value of the equation so you keep it balanced. Today we're looking at solving multiplication and division equations. And here's what I see most of the time when I am working with students who are solving equations. You'll have an equation like this, 6x equals 12. And then they will do something like this with the obelisk sign to show the division. But the problem with the obelisk sign is it doesn't really show what's happening in the equation. So I encourage you to make this one change in teaching how you solve multiplication equations so that the math you're doing actually connects to the identity, multiplicative identity. And it looks like this. So you just put a fraction bar instead of all the other writing. You don't need a total bar. When you write it like this, you can clearly see the fraction aspect and why the 6's cancel out, because 6 over 6, 6 divided by 6 is 1, and 1 times 6, or 1 times x is x. This way of doing it may seem kind of particular or petty, but I assure you, having tutored especially many students, it takes away the feeling of just doing random acts of math when you're studying algebra. And many students feel like they have no idea how you decide to do what to do in the problem. So when you do it using my big one theory technique, it's much more clear in why you're doing what you're doing. Here's how it works. We're going to be using the multiplicative identity when you're solving these equations. And that just says that any number times 1 is that number. So remember that. Just keep that in mind. Teaching equation solving like this, I always kept this in mind and wrote it on the board every time we did it because they need to remember why we're doing what we're doing. So we'll start out with a basic equation. 6x equals 12. First of all, I'd be like, okay guys, this says 6 times what number equals 12? Oh, well, it's 2. Yeah, obviously. So when we would first do equations, we would do basic fact equations, and I would let them just say, oh, well, what times 6 is 12, and say x equals 2. And that would be the entire assignment. But then I would come back with the exact same equations, and I would show them how to balance those equations using the big one theory technique, but I would add in more complicated equations, so things that would have decimal or fraction answers, or numbers that are much larger that you don't know the multiplicative facts for. So it works like this. You're trying to get x by itself on its side of the equal sign, so you have a statement that says x equals this number. That's the solution. So what I would do is I would say, okay, I have to move that 6, or I have to get rid of that 6, because I need x to be by itself. 6 has been multiplied by x. What's the opposite of multiplying by 6? Dividing. So I would show it as a fractional division, because all of your divisions in algebra are better or easier done, and even in fractions, easier done in fraction form. So perhaps when you're first learning division and things like that, using the obelisk sign is easier, but when you're solving equations, using the fraction is easier because it relates to the 6 divided by 6 is 1. But you also have to remember, to keep an equation balanced, if I do one thing to this side, I have to be fair and do the exact same thing to this side. This is now a balanced equation. So let's simplify. How do you simplify? Well, what do you see? And then I would ask my students, do you see the multiplicative identity? And when we first started, they would say, well, no, I don't see a number times 1. And then I would go back into the fact that 6 over 6 is 1. And that 6 over 6 is multiplied by x. So that is essentially 1 times x. So then we do, just like what we did in fractions and multiplying, we canceled out the 6. Because 6 over 6 is 1. And then what is 1 times x? Well, that's just x. And then 12 divided by 6 is 2. So you simplified both sides. And I would emphasize the fact that 6 divided by 6 is 1, and 1 times x is x. And that's why you divide by 6. And that's why you mark the 6's out. And in that first lesson, when we were doing this balancing equations thing, which I called brick wall, I used to have a line that I drew down the middle where the equal signs are. But that's why you are able to divide by it, and that's why you mark it out. And on that first assignment, first several assignments, I would require the kids to show that work. Because then they can see, they practice seeing it, and the more they see it, the more it starts to make sense to them, especially when you get to more complicated equations. You can also do this for division. So x divided by 5 equals 3. Basic equation. I'm going to show you both ways that I've seen it done and what the big one theory does for this one. On the left side of your screen there, you see x over 5 or x divided by 5. And I would always tell the kids that yes, it's a fraction and it's x divided by 5. It's both. So, well, what's the opposite of dividing by 5? Multiplying by 5. And I see a lot of teachers teaching it this way. You multiply by 5 on the left and you multiply by 5 on the right. The problem is here. That says x over 5 times 5. And what I would often run into is kids thinking that that side equals x over 25. And you and I both know that's not what we mean by that. But that's what a lot of students see. So if you find students making this common mistake, try teaching it to them this way. So you multiply both sides by 5, yes, but you do it such that it's in the numerator. Like this. And the 3, or any whole number, is in the numerator. I also always remind them of that any whole number is a numerator. Sometimes I would have them draw that fraction bar a little bit longer so you could see that that 5 is in the numerator. And that 5 over 5 is 1. And so those 5's cancel out the same way the 6's did in the last problem. They would cancel them out and multiply 3 times 5 and get 15. And I would do this with them also. I would have a first lesson where it's simple division facts and say what divided by 5 is 3. And have them go through and write, oh, well, x is 15 because 15 divided 5 is 3. And then again, I would go through and have them do it this way and have a few basic facts as the beginning problems showing the multiplying by 5 on both sides and how it cancels out and why it cancels out. And then later in that practice lesson, I would give them much more complicated problems that are not basic multiplication facts. Please realize that all math builds on what you teach, especially elementary and middle school math. Teach with that in mind, that it's not just about me and getting my students to pass this test, or to be able to do this problem for this moment in time, but there is something more coming. So when you teach shortcuts, make sure that the shortcuts and your memory tools have a solid math understanding behind them. So let me show you why this is so important. And I mainly got this from tutoring students in high school math, things like Algebra 2, and now I'm tutoring somebody in college algebra, and I see it in logarithms. It's pretty impressive. So, here we go. Future math glimpse. See you soon. We're going back in time. Or future, we're going forward in time. Ooh, some equations that these students will see in algebra and Algebra 2 and college algebra. Ooh, quadratics. What you may not realize as an elementary or middle school teacher is that all of those use the idea that x divided by x is 1. And teaching it young helps immensely with them understanding it later in their education. Algebra is not difficult when you have a solid understanding of basic operations. And algebra is not difficult when you understand the basic properties of operations, such as the commutative property, associative property, distributive property, and the identities. I find that a lot of teachers don't think that the identities are really all that important, but the identities are what we use to solve those equations. The identities are what we use to simplify equations. And that's how you use the big one theory to solve multiplication and division equations. Now you can take this technique and use it in your own classrooms, and hopefully to free yourself from the prison of the randomness of algebra and give your students some meaning behind what they do. Try and see the future in what you do and find the love of your subject in what you do, and in seeing that, oh, you know what, first grade math is actually done in college algebra. Second grade math is done in calculus. Third grade math, it's all building on top of each other. Any questions? Please feel free to email me or message me if you have any questions or any subject that you would like for me to do a video on. Thanks for watching. See you in class.